Welcome to Final Exam Review Practice, Part 1. Today we're going to look at the multiple choice. So I'm going to go ahead and pull up the multiple choice section here. Okay, so the following instructions will appear at the top of Part 1 of the final exam. This is a closed book, closed resource test. However, you may have one page of notes and use a 4-function scientific or graphing calculator. You will have 35 minutes to complete this test. Okay, so here's question number 1. Which of the following is a graph of y equals negative 1x minus 3? Okay, so remember, this negative 3 represents the y-intercept. So we want to look for a graph that has a y-intercept of negative 3. So that narrows it down to the first and the second choice. And then we look at the slope. The slope is the coefficient in front of the x. So the slope is negative 1. So since this graph is going downward, we know this has a negative slope. And we can verify further, this goes down 1 over 1. And that's how we know the result. So there's the first answer right there. Okay, question number 2. Given a line with a slope of negative 7 and passing through the point 4, negative 7, which of the following is the correct point-slope equation of the line? So point-slope equation is the form y minus y1 equals m times x minus x sub 1. And x sub 1, y sub 1 represents the point that you have. So the point here, 4, comma, negative 7, needs to be plugged in here for x sub 1 and y sub 1. So that gives us y minus negative 7 equals m times x minus 4. And it's 4. Okay. And then m, of course, is the slope. So we're going to, oh, I erased that all. I was not intending to do that. All right, let me try that again. Okay, so we're going to have y minus negative 7. This is my first time using this. Equals, here's the slope, negative 7. Now, x minus x sub 1. And that is going to match, well, this is y plus 7. So here's y plus 7 is equal to negative 7 times x minus 4. All right, so there's that one. Now we're going to move on to question number 3. What is the equation of the graph? So notice that we have a y-intercept here of negative 2. So right down here, this tells us that we have a b value of negative 2. And then we can also look at the slope. You can see that this is going to go up 1 over 2. So by going up 1 over 2, that means that we have a slope of positive 1/2. So if we're looking at the form y equals mx plus b, which is your slope-intercept form, then we have an m value of 1/2 and a b value of negative 2. And so here's where you have a m value of 1/2 and a b value of negative 2. So question number 3 goes right there. Okay, so now we are going to continue with the next question. Oh, yeah, I have to actually click on these. Sorry, this is a negative. Okay, click on that. All right. Y plus 7, negative 7, x minus 4. That's right. Okay. And then over here we said it was the y equals 1/2 x minus 2. Okay. Which of the following equations corresponds to the graph? Use the x and y intercepts. Okay, so back to this draw function here. If we have x and y intercepts, to find the x and y intercepts, what we do is we make ourselves a little xy table. And you plug in 0 for x, and then you plug in 0 for y, and that's going to give you your x and y intercepts. So if you consider the fact that we have a y-intercept up here at, that looks like 15. So plug in 0 for y, that would be 15 for x. And then over here, if this is 4, that's 6, that's 8, that's 9. Okay. Whoops, I was not meaning to zoom in so much. Let's turn off the draw zoom. Move this over. Okay, anyway, that's a y-intercept of 9. So we have the points, I apologize, I'm still new to this function, 0, 9, and then this one right here is 15, 0. So now we just need to see what equation matches this. Now if you plug in 0 for x for this first one, you can see that you end up with negative 5y is equal to negative 45, which would result in y equals 9, and that's good. That's what we were looking for. You can also see that's true down here for this third one, but not for the second one. In the second one, we would end up with a negative 9, so we can eliminate the second one. What about this 15, 0? Well, if you try to plug in 0 for y on this one, and you solve for x, you get actually the result is x is equal to negative 15. And that's not good. That's not going to match. So what that means is that this is answer choice A in this case. So answer choice A. There we go. Question number 5. Domain and range. Okay, so domain are all the possible x values. You can see that this parabola, as it goes towards forever, it's going to just keep going down like this forever, right? To the left and to the right, it's going to go forever as far to the right as I want it to go, and eventually it's going to go as far to the left as you want it to go, which means the domain is going to be all real numbers. And all real numbers will always be the domain for any parabola. So since you'll have a parabola given to you on the final, you can just remember this is going to be all real numbers. What about the range? You can see that the highest value here is 1. Okay, so you're not going to have any values greater than 1. So all your values for y have to be less than or equal to 1, which is going to be that answer choice right there. I don't know what the parabola will look like on the final, but you'll have to just pay attention to the y-intercept, and that's going to help you tremendously. Okay, so we're going to select these two answers right here. All real numbers, and y is less than or equal to 1. All right, question 6, match the function with its graph. Okay, so what that means is that you are going to look at your shifts. You can see here that it's x plus 3. So what that is going to do is it's going to shift the parabola to the left 3. And the reason is because when you have something on the inside of the function, this is inside because it's x squared and it's inside with a square, it's going to be a horizontal shift, and it's going to be counterintuitive. So if it says plus 3, that actually means go to the left 3. And then this negative 1 on the outside means you have a shift down by a factor of 1. Because if it's on the outside of the function, then it's going to be intuitive and it's going to be vertical. So left 3, down 1. The parabola has gone to the left 3, down 1. So the vertex is right there. Do we see any other graphs that do that? Left 3, down 1, left 3, down 1, left 3, down 1? No. The other thing is this has got to be an upward facing parabola because the leading coefficient here is positive. When the leading coefficient is positive, that means you have a nice happy parabola, like a happy face, okay? So that's a little sideways. But anyway, this is how we know that we have this graph right here, by the shift and by the fact that it's an upward facing parabola. So that gives us this third answer choice. Now for question number 7, we want to choose the graph that corresponds. So what we're going to do is we're going to start off with this inequality and we're going to add 4 to both sides. So when you add 4 to both sides, you end up with 5x less than or equal to negative 20. So that's adding 4 to both sides. Next, you divide both sides by 5 and you get x less than or equal to negative 4. So remember that when it comes to inequalities, because I don't know what kind of inequality is going to show up on the final exam, but the big red flag that you're looking for is if you multiply or if you divide by a negative number, only if you multiply or divide by a negative number do you flip the sign. Okay? So in this case, we have a positive number that we divided by 5. If you do end up multiplying or dividing by a negative number, that's when you flip the sign. And we didn't do that here, and that's why we didn't flip the sign. Okay, so x less than or equal to negative 4. Now, less than or equal to is going to be your solid dot. Solid dot. If you have a greater than or a less than one that does not have the equal sign underneath, that's when you use the solid dot. Oh, that looks like a scary face. That's fun. So here we go. Give it some hair. All right, there we go. So here we have x less than or equal to negative 4. Dun, da, da. That's your answer choice. Okay, question number 8. So the first thing you're going to want to do for this one is you're going to want to add 0.6x to both sides. Of course, you are welcome to multiply both sides by 10, and that would clear your decimal, but you don't have to do that. But if you want to do that, you can. So this is a 0.6x on both sides that we're adding. And so a 0.4x and a 0.6x, oh, very nicely in this case, give you a 1x. And then the 1x is then less than or equal to 5. Well, then that's pretty straightforward. That's going to be that choice right there. So if you multiply by 10 first, you end up with 4x less than or equal to 50 minus 6x. And you'd end up with a 10x less than or equal to, I'm going to get better at writing neatly with this thing. I really am. Okay, 10x less than or equal to 50. And then you could divide both sides by 10. And you end up with the exact same thing as we had over here with 1x less than or equal to 5. Okay, so that's that one right there. Now let's move on to question number 9. Some simple multiplication here. 9 times 3 is 27. So that narrows it down to these two central ones. And then the other thing you want to pay attention to is x cubed times x to the 5th. Remember that if you are multiplying like bases, you're going to add the exponents, not multiply the exponents. So that's 27x to the 8th power, which is this one right here. 27x to the 8th power. Okay, question 10. Simplify without negative exponents. So we have b to the 0, and we have, hold on, let me change the scroll here so you can actually see this problem. Okay, b to the 0 is just 1. Anything raised to the 0 power is just 1. So I have b to the 0 and b to the 5th. If you add the exponents of 0 and 5, you get 5. So I have b to the 5th still. And then g to the negative 1 and g cubed. If you add negative 1 and 3, you get 2. remember, you just add the exponents. When you are multiplying like bases, you add the exponents. So b to the 5th g squared is that answer choice right there. All right, now we have question number 11. And this one, we have the power rule and the quotient rule combined. So let's start with the power rule. In the numerator, when you have a power raised to a power, that's when you multiply. So this is where we get in the numerator x to the 24th power. And then for the denominator, we still have this x to the negative 2. So first I used the power rule, and now I'm about to use the quotient rule. With the quotient rule, if you have the same base and you're dividing, instead of adding your exponents, you're going to subtract the lower one from the upper one. And if you subtract a negative 2 from a 24, 24 minus negative 2 is not 22 but 26. So it's that answer choice right there. Next we have a FOIL problem. This is a first, outer, inner, last, pretty straightforward. So first, x times 2x is 2x squared. Outer, x times negative 4 is, sorry, that's not supposed to be an equal sign, that's just supposed to be a negative sign. All right, negative 4x. Inner, 5 times 2x is 10x. And then we have last, which is 5 times negative 4, and that's negative 20. Right, so then when you combine that, 2x squared minus 4x plus 10x, this combines to be a positive 6x. So since we have a positive 6x in the middle, that gives us the second answer choice. Now these problems get a little harder. What we have in question number 13 is we need to factor, okay? So what we're going to do is we're going to take this x minus 5 on top and copy it as is. For the denominator, we're going to factor, I hope I can actually fit these in here, x squared minus 8x plus 15. We want two factors of 15 that add up to 8, and that would be 3 and 5. And since they have to add up to a negative 8, both the 3x and the 5x both have to be negative. So we have a negative 5x for the inner product and a negative 3x for the outer product. So for the second fraction, we just copy as is. Of course, you don't have to show any work on the final. You can do this on scratch paper. And then we're going to check off things that match. So x minus 3 matches with x minus 3. X minus 5 matches with x minus 5, so they cancel, leaving you with a 1 over x minus 2, which is that last answer choice. Okay, and then we have another one of these, except it's a quotient. So we're going to start by taking the first fraction, copy as is for the numerator, x plus 5. The denominator needs to be factored. So we need to find two factors of 20 that add up to 9, and that would be 4 and 5. So we're going to have an x plus 4 and an x plus 5. And then quotient divided by, remember we turn divided by into multiplication by flipping over that second fraction. So here we have an x plus 4 now in the numerator and the x minus 5 now in the denominator. And let's see what cancels. X plus 4 cancels with x plus 4. X plus 5 cancels with x plus 5, leaving us with a 1 over x minus 5, which is this last answer choice. Okay, now to do this subtraction problem, we need to have a common denominator. So we need to take this first fraction, 9 over x minus 8, and this second fraction, 4 over x plus 8. We need to multiply the numerator and denominator of both of these by the same thing, because you can only ever multiply by 1 if you have an expression. So what we want to have is matching denominators. So this denominator needs to become x plus 8, x minus 8. This denominator also needs to be x plus 8, x minus 8. Whatever I multiply in the denominator, I also have to multiply in the numerator to make it legal. So what does that give me now? Well, my new denominator, x plus 8 times x minus 8, is a difference of squares, x squared minus 64. And for my numerator, I have a 9 times x, which is 9x, minus 4 times x, which is 5x, right? 9x minus 4x is 5x. And then I have 8 times 9 is 72. This is a minus minus here. So this is negative 4 times negative 8, so that's 32. Negative 4 times negative 8 is positive 32. So I have a positive 32 and a positive 72, which leads me to a positive 104. And that would be this answer choice right here. Okay, so for question number 16, I have addition. It's the same situation. So for this first one, I'm going to multiply it by an x plus 3 over x plus 3. For the second one, sorry, that's the one on the right. The one on the left now, I need to multiply by an x plus 2 over x plus 2. So two things I want you to notice is that when you're dealing with expressions, and these are expressions because they're not equations, you can only ever multiply by a form of 1. So this is a form of 1, and this is a form of 1. And the goal is to create a denominator that is matching. So x plus 2 times x plus 3 matches x plus 2 times x plus 3. So the combined denominator is going to be x plus 2 times x plus 3. And don't worry about multiplying that out. Look at all the answer choices. They didn't multiply it out, so you shouldn't either. Okay, now let's look at the numerator. Negative 4 times x plus 5x. Well, a 5x and a negative 4x combine to be a 1x. And then we have a negative 4 times 2, which is negative 8. And a 5 times 3, which is 15. So we have a 15 and a negative 8, and 15 and negative 8 add up to be 7. So that gives me the last answer choice here. Okay. So this one is a nice, easy, simple notational one. Remember that when you have a 14 in the denominator, that's going to be the root. So the index of the root is 14. So this one is just really simple. The numerator tells you what the variable is raised to inside the radical. The denominator just tells you the index of the radical. So that's it for number 17. Number 18, we want to simplify this one completely. So we're looking at 6 times, and here we have the 5th root of 64, and I'm going to split up the 5th root into 2 5th roots. Okay, so 64 is actually 32 times 2. And 32 happens to be 2 to the 5th power. So here's something to note. 2 to the 5th power is equal to 32. It's a good handy thing to memorize. So then x to the 17th, we want to take the exponent and make sure it's divisible by 5. So we have x to the 15th, and then we have x squared. So 15 is divisible by 5. So this is my perfect 5th power. And I'm going to simplify that one in just a second. Okay, so this is supposed to be 5th root. Sorry about that. Alright, so this simplifies into 2 times x cubed. And that's because the 5th root of 32 is 2. And the 5th root of x to the 15th, you just do 15 divided by 5, and that's x cubed. So now we have 6 times 2, which is 12. Okay, so that's going to be one of these 3. And then x cubed. Alright, the only one that has x cubed on the outside is the first one. And then a 5th root of 2x squared, that matches. So make sure it matches all the way across your whole answer. Alright, next, number 19. Solve the equation. So this is nice and straightforward. I'm going to start by subtracting 12 from both sides. So when you subtract a 12 from an 81, you end up with x squared is equal to 69. Okay, that did not work out. Let me try that again. Erase. X squared is equal to 69. Now we're going to use, oh gosh, come on, 69. Now we're going to have to take the square root of both sides. Now when you take the square root of both sides, don't forget that you have to have the plus minus, and make sure it's on the right hand side here. So x is then equal to plus or minus the square root of 69, which is your first answer choice. Now, for the next question, number 20, you got to use the quadratic formula. And so you want to have that in your notes if you don't already have it memorized. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what is the a value? The a value is negative 1 because the coefficient here, the leading coefficient, is negative 1. The b value in this case is positive 5, and the c value is 3. So now we just replace a, b, and c with negative 1, 5, and 3. So a negative b in this case would be a negative 5. Then we have plus or minus the square root b squared. If we square b, we end up with 25. So 25 minus 4a c all over 2a. Okay, so one thing is to notice this negative 4 times negative 1 is positive, so this is actually 25 plus 12, and 25 plus 12 is 37. So now we're looking at one of these ones right here. So all of these say plus or minus root 37. So what's the difference between them? Well, the denominator here is a negative 2, so it's not going to be the one with the denominator of negative 1. And then this one right here is negative 5 plus or minus root 37 over negative 2. This one is positive 5, and we have a negative 5, so we don't want this one either. So that means that this is the answer right here. Okay, vertex. To get the vertex, what we're going to do is we're going to use the vertex formula, which is negative b. So negative b. Try that again. Negative b over 2a. And that's going to give us the x-coordinate of the vertex. So negative b would be a negative 4. over, that's supposed to be a 4, 2 times a. So our a value is 1, and our b value is -4. So this becomes a positive 4 over 2, which means that we have an x-coordinate for our vertex of 2. So that means it's not going to be one of these. Now we plug 2 in, and when you plug 2 into here, you get 2 squared, which is 4, minus 4 times 2, so minus 8. So you're going to have y is equal to 2 squared is 4, minus 4 times 2, minus 8, plus 21. And if you add all that up, that is 17. So that means my vertex is at 217. Identify the equation for the graph. Okay, so I can see right now that this is a downward facing parabola, and because it's a downward facing parabola, okay, let me try that again. Because it's a downward facing parabola, that means that the leading coefficient has to be negative, okay? The leading coefficient, remember, is a, and a has to be negative. So we're not going to have this one. That's a positive leading coefficient. That's a linear equation. We don't want that one. That's another positive leading coefficient. That's another linear equation. Make sure that this is going to be an x squared, okay? We do not want a linear equation representing a parabola. So now we are left with just 2 choices. So remember, if it's a downward facing parabola, if it's a sad parabola, the leading coefficient, the number out in front, is going to be negative. If it's a happy parabola, the leading coefficient is going to be positive, okay? Positive leading coefficient, happy parabola. Negative leading coefficient, sad parabola. Okay, so what about this? This y-intercept down here is at -3. So the y-intercept we can see right here, the c value is your y-intercept, which means that the second choice is correct. This one, y equals 10 to the x power, that's exponential growth. Anytime you have this value right here that's bigger than 1, this is the form y equals b. Okay, let me try that again. Y equals b to the x power, and if b is greater than 1, what you have is exponential growth. So the graph is always going to look the same. It's always going to start off low here, and then it's going to shoot up really fast. It will always look like this when you have a b value that's greater than 1. And in this case, our b value is 10. Okay, so here's my exponential growth. Last question. The general form of a circle is going to be x minus h squared plus y minus k, and this is all squared, equals r squared. R squared. So, what is h and what is k? That would be the center. So the center of my circle is going to be h k. Center. All right. And then r is your radius. So what I'm going to do is look over here at the center, and the center I can see is at -3, 1. -3, 1. And what's my radius? My R value is 1, 2, 3. Takes me 3 boxes. Okay, so what I need to do is find an equation that matches this. R is equal to 3, so R squared is going to be 9. So it's either going to be this one or it's going to be this one right here. Now, when you do x minus h, x minus -3 is actually a positive 3. And that's what you see down here in this bottom one. X minus -3 is a positive 3. And then y minus 1 is what we would expect for here. So these ones are backwards. They forgot to subtract. They didn't use the subtraction. So the answer choice is this last one. Okay, moment of truth. I get to find out if I got these all right. Submit. Yay! Okay, so that's how you do Part 1 multiple choice of the final exam. Remember, when you get to the bottom, if you want to try similar problems for the ones that you missed, then you want to select here. Try similar problems for all questions with less than perfect scores where allowed. Reattempt assessment would let you go back and see what you submitted and compare it to the real answers. It's not going to actually let you reattempt it, but it would let you at least see what the answers are. And then create new version would allow you to come up with a whole new version. Uh-oh, this is me. All right, so I have to log in again, and I'll do that at another time. All right, see you in part 2.